Hello guys, so we are going to continue the discussion with respect to statistics, and in this video we are going to discuss about histogram and skewness. So this is a really important topic, and from this probably as we go ahead we'll also be understanding about various distribution of data. Okay, so first of all, let's go ahead and understand about the definition of histogram. Histogram is a graphical representation of a distribution of numerical data. It is an estimate of the probability distribution of a continuous variable. Let's say if you have a continuous variable, I really need to understand how the distribution of that particular variable is. I can actually use histogram. And it is used to visualize the shape and central tendency and the variability of a data set. Okay. So this is the basic definition of histogram. We will also be discussing about a topic which is called as skewness. Now let's take a specific example. So here, let's say that age is one of a random variable that I have. Okay. And let's say I have values like 11, 12, 14, 18, 24, 26. I'm sorting this particular numbers just to make my work easier. Okay. 30, 35, 36, 37, 40, 41, 42, 43, 50, 51. So let's consider that I have this, all the numbers that are there with respect to the ages. Okay. Now we will try to construct a histogram for this continuous values. Okay. So what are the step-by-step method that we will specifically follow? Now, first of all, you'll try to understand here my numbers are ranging between 11 to 51. Okay. So if it is ranging between 11 to 51, okay, or let's say my last number is 50 over here. Okay. So my numbers are ranging between 11 to 50. Let's say I will just go ahead and consider all my histograms will be ranging between 0 to 50. Okay. Now in this case, first of all, we decide, the first step is that we decide the number of bins that we are going to use to show this entire distribution in the form of histogram, right? Let's say if I go ahead and select the number of bins is 10. Okay. Now what does this basically mean? I will try to show the histogram of this entire distribution between 0 to 50 by taking this 50 number, and then we will just go ahead and divide by 10, right? Because their total number of bins are 10. If I go and divide by 10, I'm going to get 5. So 5 will basically be my bin size. Okay. Bin size. Now what does this basically mean? The 10 bins that I'm actually going to create, the first bin will be between 0 to, since my number over here is, the bin size is 5. So here you'll be able to see that the number of bins that I'm actually going to create, right? My bins, first bin will be ranging between 0 to 5. Then I specifically have, or let's say that then I'll be having 5 to 10. Then my third bin will be 10 to 15. Then I'll be having 15 to 20, 20 to 25, right? 25 to 30, 30 to 35. Like this, we will go till 45 to 50. So this will basically be my bin size. Okay. So let's go ahead and draw this entire diagram. So first of all, over here, you'll be having on the y-axis your ages. Okay. This ages will be defined based on bins. Let's say that I'm starting the bin from 5 because 0 to 5, I don't have any data over here. Okay. So I'll directly start from 5. Then my next bin is basically 10. Then you have 15. Then you have 20. Then you have 25. Then you have 30. Then you have 35. Then you have 40. Then after this, you basically have 45, then you have 50. Okay. So these are my ages. Okay. And this is specifically my count. Count, what do we say with respect to this particular count? This is nothing but frequency. Now what this frequency basically indicates, I'll just talk about it. Okay. Let's say one frequency, I'm just going to write 1 over here, 2 over here, 3 over here, 4 over here, and 5 over here. I'm just trying to show you how do you construct a bin. Okay. So this is my entire distribution, as you all know. So I'll just copy this entire distribution. I'll paste it over here so that I have my entire distributions mentioned. Okay. Perfect. Now let's go ahead and see how many numbers are basically present between 5 to 10. So there are none of the numbers that are present between 5 to 10, right? But how many numbers do we have between 10 to 15? So we'll just go and count 1, 2, 3, right? So 1, 2, 3 basically means 3 numbers. So what we are going to do is that we are going to basically draw a building like graphs, okay? And this will basically indicate that, hey, there are 3 numbers between 10 to 15, right? And this is how we go ahead and create a histogram. Now this 3 that you will be seeing is the frequency or the count of the number of elements that are present between this particular bin. Then we go to the next bin, 15 to 20. 15 to 20, there is only one number, that is 18. So let's go ahead and construct this next bin, okay? Next histogram, okay? Then we'll go between 20 to 25. So 20 to 25, only there is also one number, that is 24. So it will come over here, right? Then between 25 to 30. So here you will be able to see I have 25 to 30. It is nothing but one number, two number, right? But this 30 can also be put up in 30 to 35, right? So if we consider that, for a specific bin, let's say in the case of bin that is 25 to 30, any number that is greater than 25 and less than 30 will be included over here. So 25 to 30, how many numbers are basically there? Only one number, because 30 is not less than 30, right? It is equal to 30. So in the next one, what we will do, or I can also write this condition as any bin, let's say between 25 to 30, if I have a number greater than or equal to 25 and less than 30, I will try to include it over here, right? So in this particular scenario, only 26 is the number that is present. So here I am going to again construct one specific bin, okay? Then you have between 30 to 35. With respect to 30 to 35, I have one number 30, but 35, it is equal to 35, but I need to have less than 35. So here again, I will go ahead and construct my another bin that is for the number 30, okay? Now between 35 to 35 to 40, you will be able to see that I have two numbers, 1, 2, 3, right? Sorry, 3 numbers are there. So we will go ahead and construct our next bin that is between 35 to 40, which I have is nothing but my 3 frequency with respect to this particular number, okay? Then between 40 to 45, so here you will be able to see between 40 to 45, I have 1, 2, 3, 4, right? So 4 numbers are basically there. So we will go ahead and construct one more histogram, which will basically have the count as 4, okay? And finally, you'll be able to see that, do we have any number between 45 to 50? So 45 to 50, none of the numbers are there, because 50 greater than 50 will be one more number. So let's say if I have 55 over here. So here we are just going to construct one more with bin size as 1, okay? So this is my entire histogram that is basically getting created, okay? And with respect to this particular histogram, you will be specifically able to work and see. And this basically shows the distribution of this numerical data. So what this is basically showing, it is showing the distribution of the numerical data, right? Numerical data. Now, one term that you have heard of, right, in the definition, which is called as probability distribution of a continuous variable, right? Now, how do we create this probability distribution of a continuous variable? It is very simple, guys. What we do is that for this entire histogram, we will try to smoothen this histogram. So when we smoothen this, you will be able to see my graph, my entire distribution will look something like this, okay? And this smoothing is basically called as probability distribution function, okay? This is nothing but it is called as probability distribution. So if you go ahead and see the definition of a continuous variable, okay? Of a continuous variable. Now, how do you create this smoothing? We use a technique which is called as kernel density estimator. So right now I'm just giving an idea, but we will discuss more about this as we go ahead, right? But you got an idea. Whenever, first of all, I construct a histogram, this basically shows the distribution of a continuous random variable, right? But if I'm smoothing this histogram, this will probably show you the probability distribution of a continuous random variable. So this kind of distribution, right? how my distribution is basically looking with respect to our random variable, right? So this was about histogram. So in this video, I have actually spoken about what is a histogram. Then we took a problem statement. Then we try to create a histogram over here. Okay. Now let's talk about, and we'll discuss about this kernel density estimator as we go ahead, because this is a very important topic. And you will be seeing that how this PDF is basically created, which we say it as probability distribution function. And there is also something called as probability density function, probability mass function. We will discuss about that in the upcoming modules. Okay. Now let's discuss about another one more important topic, which is called as skewness. Now what exactly is skewness? See, let's say if I go ahead and create a histogram, okay, and let's say the histogram looks something like this. Let's say my histogram looks something like this. Okay. Now in this particular histogram, if I smoothen this curve, you will be able to see that we will get this perfectly bell curve, right? This is a kind of a bell curve. It is a perfect bell curve. And with respect to this particular bell curve, so if I go ahead and smoothen this, okay. So this is a bell curve. Now this kind of curve, like if we have a distribution which creates this curve, this is called as normal or Gaussian distribution. We'll discuss about normal or Gaussian distribution, but you can just understand that this distribution is exactly a bell curve, right? A bell, it's just like a shape of a bell itself, right? So like this, perfect shape. And this distribution is called as symmetrical distribution. Why symmetrical distribution? Because if I divide this bell curve into two parts, let's say if I divide it from here, which is my mean, right? And this is my mean. This part will be equal to this part, right? That basically means what do I mean by this part will be equal to this part? That basically means the variables or the values in that continuous variable, how much it is present over here, it will be present similar in numbers over here also. So both the sides will be equal, right? If 5 numbers are basically present over here also 5 numbers should be present, right? And that would form this kind of distribution. So this is basically called as symmetrical distribution. Okay. So in symmetrical distribution, there will be no skewness. It is perfect in shape. 50% of the probability of the distribution will be available over here. 50% of the probability of the distribution will be available over here. Let's say if I have a continuous variable with respect to ages, right? And if I say, hey, ages follow this particular values or this distribution follows a symmetrical distribution, that basically means 50% of this distribution will be available on the left hand side of this particular line, and it will be, and remaining 50% will be available on the right hand side of this particular line, right? Which is basically mean, median or mode. Okay. Now, let me talk about more about this symmetrical distribution. As I said that there will be no skewness. Okay. So let's say if I go ahead and construct this distribution, let's say if I have this entire distribution, which looks like this. Okay. So here, you know that this will be equal to this, right? That basically means no skewness will be there. Now, there is something called as box plot. And you really need to understand what exactly this box plot is. I've already discussed about 5-number summary, right? So in 5-number summary, based on the 5-number summary, we also go ahead and create a box plot. A box plot is something which has this kind of lines, okay? It looks like this particular box. This is your minimum. This is your maximum, okay? This is your Q1. This is your Q2, which is median. And this is your Q3, okay? In the case of symmetrical distribution, and this is your minimum and maximum value. Okay. So whenever I try to create a box plot based on a continuous random variable, it looks something like this. Okay. Q1 is nothing but it is your 25 percentile. Q2 is nothing but it is your 50th percentile median, right? Q3 is nothing but it is your 75 percentile. And this is your minimum and maximum value. Now, one amazing thing about this particular box plot will be that in the case of a symmetrical distribution, if I subtract 75 percentile minus 50th percentile value, this will be approximately equal to Q2 minus Q1. Okay. That basically means your median will be exactly present. Your mean, median and mode will be exactly present in the center, right? So based on the skewness, since you can see that this is an exact symmetrical distribution, here I will go ahead and write a point. The mean, median and mode are all perfectly at the center. And this can be one very important interview question. In some of the interviews they have asked, what is the relationship with respect to mean, median, mode based on varied skewness of a graph? If it is a symmetrical distribution, then what is the relationship between mean, median, mode? So since this is a symmetrical distribution, I know my mean will be this, my median will be this, and my mode will be this, right? Because it is exactly symmetrical. And if I consider with respect to the box plot is something which we specifically construct to find out outliers, right? If I have outliers, that numbers will be present over here, it can be present over here, right? But this value basically talks about minimum value. This is nothing but 25 percentile value. Let's say this is my numbers over here, right? This is my 75 percentile. And since it is a symmetrical distribution, this box you can see, right? The median is exactly in the center. The mean is exactly in the center. Okay. So in this particular case, if I just want to give a notation, mean is equal to median equal to mode. Okay. So this is the property that we specifically get through this. Perfect. Now this was one of the scenario in skewness. Okay. Now let's talk about the second scenario. The second scenario is something called as right skewed. Now what does this right skewed basically mean? What is this right skewed? Okay. So if I go ahead and construct a graph. Okay. Now what does this right skewed basically mean? Okay. Right skewed is nothing but, let's say if I have a histogram which looks like this. Now, if I take this kind of histogram, this histogram is basically called as light skewed because we also said this as positive skewed. Because if I just do the smoothing of this graph, just see, okay, the entire skewness is bent something like this, right? So this is how my distribution will look like, right? If I try to just plot my histogram with respect to smoothing, if I just smoothen this particular graph, it will look something like this. Now, the reason it is called as right skewed, because see, the right side of the curve is elongated. What does this basically mean? This indicates that here we have a lot of outliers. Okay. And one type of distribution that follows this particular pattern is called as log normal distribution. We'll discuss about this. These are some very important distribution. Log normal distribution. Okay. Because we'll be discussing about all the distribution techniques in much more depth, right? So whenever in the right hand side you have a lot of outliers, so that entire distribution will be right skewed distribution. Okay. We can also say it as positive skewed. Now in this scenario, we need to understand what is the differences between the mean, then median and mode, because we need to find out the relationship with respect to all these values also. Do you think the mean, median, mode will be same for this kind of distribution? Just think over it. I've drawn 3 lines. Just tell me which one will be mean, which one will be median, and which one will be mode, And how do you identify this? That is really much important. See, if you have an outliers, right? If you have an outliers, in the case of outliers, what is the value that is mostly impacted? Just think over it. Whether it is mean, median, or mode. The answer is simple. It is mean, right? So here, if I go ahead and say in right skewed distribution, the mean will be greater than or equal to median. It will be greater, median will be greater than or equal to mode, right? So this is the relationship that we specifically have in the case of right skewed distribution. Now in this example, what do you think will be your mean? What do you think will be your mode? And what do you think will be your median? As I said, mean is always greater than or equal to median, is always in greater than or equal to mode. So from these three lines, you can probably see that yellow line will be mean, median will be the red line, and orange line will be the mode. Okay. So this is how you basically identify, and this is the relationship with respect to mean, median, mode. Now, if I go ahead and construct the box plot, now this time my box plot will look something like this. Let's say if this is my distribution, this is my minimum value, this is my 25 percentile, then I will just go ahead and create this box, and this is my maximum value. Now, since my mean, see, this is indicated by Q1, this is indicated by Q3. Q3 is 75 percentile, right? If I say with respect to the box plot usually in box plot, the 50th percentile will be the median, right? So here the median value will be somewhere here. I'm just considering it. The median value will be somewhere here because why? Because mean is nothing but it will be in the center, or it may be somewhere over here. But in this scenario here, you will be able to see the median will be somewhere over here, because in this particular case, this is the relationship, right? Median, mean will be greater than or equal to the median. So that is the reason you are able to see that the median value is a little bit less and it is shifted towards the left hand side. The reason is very much simple. Why it is shifted towards the left hand side? Because this is right skewed, right? And here you may also have some kind of outliers, okay? Because this distribution with respect to the box plot indicates the right skewed distribution. The right skewed distribution in this particular scenario, the mean will be shifted to the left, okay? So this is what we have, right? And similarly, with respect to this particular relationship, if I go ahead and subtract Q3 minus Q2, it will be greater than or equal to Q2 minus Q1, okay? This is very much clear just by seeing the line, okay? Since this is right skewed distribution, here you can see median will be shifted towards the left. This area will be more because the outlier will be there, right? Now coming to the third type, obviously just by understanding this now, if we are discussing about right skewed, then we also need to discuss about left skewed distribution. So the left skewed distribution over here, it's very much simple. This time your graph will look something like this. Let's say this is my graph. My distribution will look something like this. Okay. Now in this scenario, again, I will draw three lines. This one, and this one. Okay. Now in this scenario, what do you think is the relationship between mean, median, mode? Now you can think over it. It is very much simple. Since this is left skewed, so you have smaller numbers. Smaller numbers are nothing but outliers. If you have more smaller numbers, then what will happen? Your mean will be less than or equal to median. It will be less than or equal to mode, right? So this is the relationship that we specifically get. And this is nothing but, this is also called as negative skewed. Now, if it has negative skewed, if I go ahead and construct the box plot, the box plot will look something like this time, okay? So I have my minimum value, then you have this, then we will go ahead and construct this, okay? Then similarly, we'll go ahead and construct this, right? And this is my Q1, this is my Q3. But what about my Q2? It will be present somewhere here because it is left skewed. More data is present on the left hand side. So in this scenario here, if this is my numbers, I can just directly say that, hey, my Q2 minus Q1 will be greater than or equal to Q3 minus Q2, right? So this is the relationship that we specifically get with respect to the left skewed distribution. So this was it. With respect to the skewness, you have three different types. One is the symmetrical distribution, then you have right skewed distribution, then you have left skewed distribution, and you understood the difference. And you also understood the relationship between mean, median, mode. Okay. Let me quickly again revise this. Why right skewed will have mean greater? Because there will be an outliers. And you know that outlier get impacted, the mean gets impacted because of the outliers. If there are more outliers, then what will happen? The mean value will increase. Similar thing will not happen in median and similar thing will not happen with mode, right? And again, with respect to the box plot, you will be able to see that this width between your 50th percentile and 75th percentile will increase, which is also median, right? And Q3 minus Q2 will be greater than or equal to Q2 minus Q1. Similarly, in the case of left skewed distribution, it is in this shape. Here your mean will be less than or equal to median, less than or equal to mode. The reason is very simple, because here also you have outliers, but the outliers that you have is with respect to the smaller numbers. So it will definitely impact the mean itself, right? So mean will be having the lesser value over here. So this was all about the histogram, and we have also solved a problem. We have also made you understand about the entire distribution, how to construct a histogram, and we have discussed about the skewness. So yes, this was it from my side. I will see you all in the next video. Thank you.